Okay, so this problem from our notes is a preview of the calculation that we're going to be doing in our first lab this unit. So it goes like this. We have 3 isotopes of the element beanium. And these isotopes are all mixed together in one giant bag. And we want to try to figure out the average atomic mass. That's the goal, right? To calculate the average atomic mass. And of course, as you know by now, this is a weighted method. Here, this is just all raw data. What we need to do is we need to process this data a little bit so that we can carry out that calculation. So I'm going to need more space. I'm going to add a page here underneath here. Okay. So first, let's find the average mass per bean for each category. So focus on bean type A. If I said, what's the average mass of bean type A or of isotope A, without overthinking it, how would you find that? Yeah, let's just divide, right? So average mass per bean. Okay, so for A, when we say mass per bean, think of the units. Does that mean beans per gram or grams per bean? Mass, it says mass per bean, right? And mass is grams. So this is going to be in grams per bean. So if you can figure out what unit that is, then you just figure out how to calculate this. You're going to take the 34.86 grams, you can divide it by the number of beans. Okay, so my mass value was recorded to the 100th place, so that mass value has 4 sig figs. The number of beans is a counted object, so 198 does not have a limit on sig figs. So the number I write down here, 0.176060606, we're just gonna have to call it 0.1761. Okay, we did that for the first one. Let's do that for the second one. 29.74 grams per 131 beans. .2270 grams per bean. And then the last one, 16.75 grams over 92 beans. 0.1821. Okay, so that part's done. That average mass per bean, this section right here. Next, calculate the decimal abundance of each type of bean. Okay, we should know how to do this because we just did an example of that, right? The abundance in decimal form. In order to find the abundance in decimal form, what is the first thing you need to do? The total number, right? So our total number of beans is 421, which means our abundance is going to be 198 over 421. And actually, I'm not even gonna write that because I'm not gonna be able to round that. I'm just gonna leave that as a fraction. 131 over 421, 92 over 421. Okay, I have my decimal abundance. I have my I have my average mass per isotope. Now I can calculate the overall average mass. So let's go ahead and do that. So for A, 0.1761 times 198 over 421. Oh, 0.08282 0.2270 times 131 421. Point 07063. 1821 times 92 over 421. Point 03979. Okay, we have 3 subtotals. Let's add them up. All these have the same, or do they? 1, 2, 3, 4, 5. Yeah, they all have the same number of decimal places, and we're adding, so that will be the answer that we go with. And this is grams per bean. Okay, this method of tabulating these values from raw data, this is exactly what you're going to be doing in the Beanium lab. All right, you are going to get a sample of beans. There's going to be different types in there. The first thing you need to do is sort them into different categories. And then you need to count how many there are in each category. You need to establish your count, right? And then you're going to need to find the total weight. Like look here, right? All of the A isotope weighed this much. So you're going to put a weighing boat on a scale. You're going to press 0. You're going to add your beans, the first bean type, and record the total mass. And you're going to do that for each of these. And once you get all your numbers, then you can start processing the data. When I say process the data, I mean you come up with these last 2 columns here, and then you can use those values to calculate your average atomic mass. Mass? With your hands. Oh, they're very visibly apparent. They're very obviously different, right? They're as different as like M&M colors. Okay. Okay.